Hi everybody, welcome to another video in Math 1332, section 11.5. Probability with fundamental, counting principle, permutation, combination, and every other techniques, common techniques. Right, first we study about the tree diagram. A tree diagram is a diagram consisting of branches corresponding to the outcome of two or more probability experiments. So have two or more probability experiments. Right, for example, so that's multi-stage problem. So use a tree diagram to find the sample space for the genders of 3 children in a family. Right. So the first child could be the boy or girl. And doesn't matter what we choose there. The second child can be a boy or a girl. And then the third child, doesn't matter, it will be a boy or a girl. And then when we list the sample space, we just trace along the branches of the tree. So we will list the sample space will be equal to a set of all boys, boy, boy and girl, boy, girl and boy, boy, girl and girl, a girl, boy, boy, a girl, boy and a girl, a girl and boy, and all girls. That's the sample space. There are 8 possibilities. Now this is pretty much like the true-false table we did earlier the semester. Right, so that is a sample space. If a family has 3 children, so in that case, a 5 probability that they have at least 1 boy and 1 girl. Right, so we just count. What is the probability of getting at least 1 boy and 1 girl? At least. So event 8, at least 1 boy and 1 girl. So excluding the case of all boys and all girls, that's what left, right? Except all boys and all girls. This have at least 1 boy and 1 girl, so there's 6 of them. So probability of getting that event of at least 1 boy and 1 girl is how many we have in E over how many we have in S. And in E we have 6, S we have 8, so that's 3 over 4. Right, next we have there are 32 chocolates in a box, all identically shaped. There are 11 filled with nuts, 8 with caramel, 13 with solid chocolate. You random select one piece and eat it, and then select the second piece. Find the probability of select 2 nut candies. The key here is we eat it. Right, now let's see. There are 32 in total, right? So first, right. So first, there are 11. Let's list that will be nuts, caramel, and solid. Let's use O for that. S for solid. And you eat it, and after that we have the second case. There's nut, caramel, and solid. nut, camel, and solid. Now, one thing different but this problem and the previous problem. Doesn't matter what we have on the first child, boy or girl. The second one is supposedly independent to that. So we don't really have to write probability for each case. This is different. Every time, doesn't matter what we choose, it will affect what we choose on the second time. We'll see. There are 32 in total. Originally there is 11 filled with nut. So the probability to get that is 11 out of 32. That is probability of getting nut on the first one. And then there are 8 caramel and 13 out of 32. Right. And after you eat the first one, let's say you choose the first one's nut, already ate it. So there's only 10 nut left out of 31 because you already ate one. So it's like that. And with that we can complete the rest of the tree here. So probability of getting the chocolate and then a nut. You only ate one of the caramel. So there will be 11 nuts left out of 31. Just like that. And after that, the question asks what is the probability of selecting 2 nut candies. So the first one's nut is 11 out of 32. The second one have to be nut as well. There are only 10 left. If you ate the first one, there are 10 nuts left. And you ate one, so there's 31 left. So that is the probability. Multiply the top, 11 times 10. Divide by the bottom, 32 times 31. And we can change this to fraction. 55 over 496. Or we have 0.111. Just round up. Right, be careful when we use the tree. When we write the tree, make sure that if the probability will be the same, we don't really need to write that. But the probability are different. We have to write for every range. And then for each outcome, we have to multiply every number on the branch. So for example, if the probability of getting the first one is a caramel, the second one is nut, we multiply these two numbers together. Just go along that path and multiply all of the probability on that path. Right. Next, consider the political discussion group consists of 7 Democrats, 7 Republicans, and 3 Independents. Suppose that 2 of them are selected in succession to attend a political event. Find the probability that an Independent and then a Republican will be selected. Right. So again, in the first case, there will be 3 scenarios each. Democrat, Republican, and Independent. Right. As far as probability goes, originally there are 7 Democrats out of 17. Yeah, 3 plus 7 plus 7, that's 17. Republican, same way, 7 Republican out of 17. Independent, 3 out of 17. Of course, we don't have to draw the whole tree. We just want the path that interests to us. Right. Next we have, because for each one there are 3. Each one there are 3. Right. Now what interested to us? Well, we want the first one Independent, but then the Republican. Now, if the first one, we select one of them, it's going to be 16 left. If the first one is select as Independent, one of those 3, that means there will be 7 Republican left. So if we want Independent and then Republican. Independent, that 3 out of 17 from the beginning. After that we have 16 and 7. So that's what we have. I multiply straight across. Convert to fraction. Right. Yeah. Next, find probability of select both independent. Well, both independent. Originally there are 3 independent. When you select the first one, there's 2 left. And you select 1 out. So that's 2, 16. So you get independent and independent. The first one is 3 out of 17. After that, there are 2 independent left out of 16. Right. Again, I multiply straight across. 3 times 2. Divide by 17 times 16. Convert to fraction. Just like that. So, like I said, when we get used to it, we don't really need to draw the whole tree. We just draw the branch that we want. Of course, we can, if the probability are the same, we don't really need the probability on each of the branch, and we just count. Just principle of counting. Right. This one probability are not the same, so we have to write it, and then we trace along the path, add all the probability on that path. So that is a tree diagram. Now we use a table. Construct a table of all possible outcome of rolling 2 dice. Well, 2 dice. Each die have 6 outcomes. So 1, 2, 3, 4, 5, 6. One, two, three, 4, 5, 6. Right. So draw a table like that. Actually, this is the first line. Actually, let's make that the second line. First line is here. First line can have 1, 2, 3, 4, 5, 6. So the first I can get 1, or 2. Of course, we can draw a tree diagram here, but that will be very crowded. Go to 6 branches, and then for each one there's 6 branches again. That's the first one. Now second die. Could be 1, 2, 3, 4, 5, and 6. Let me write the comma first. Right, now have 1 on the second. 2, 3, 4, 5, and 6. Right. And because there's 6 for it would talk about the tree diagram. Have 6 branches and each and correct 6 again. So 6 by 6 there are 36 possible outcomes. And find the probability that the rolling pair of 2 dice getting their sum of 10 or higher. So we write E is the event of 10 or higher, or 10 or more. Now we just list everything. 10 or higher. This is 10. So 4, 6, 5, 5, and 6, 4. And then 6, 5, 5, 6, and then 6, 6. So that is that event. So probability of getting that event, the sample space here, there's 36 of them. So we have 6 here. Just say it. There's 6 out of 36, or 1 over 6. Right. Again, we just count. Right. Next, a survey was conducted by the Gallup organization, and we have this about this. So what is the probability that a selected Afro-American who live in the East believe in God? Right. So we have to select who lives in the East. Live in the East. Total, we have to find the total here. Of them on East. Be 204 plus 36 plus 15. That's 255. So 255 people live in the East. Out of those believe in God is 204. Right. Again, discount. How many we have total? 255. And out of those, how many believe in God? About 80%. What is the probability that the random select Afro-American who believe in God live in the East? So believe in God, we have to add all of this up. $204 plus 212 plus 219 plus 152, 786, 787, and out of those who live in the East is 204. So that. .259. Use the following table to find the probability that one card is selected at random. The card is a jack. A jack here. If we want to select at random and get a jack, there are 4 of them. Have 52 or 1 out of 13. Probability that getting a queen or a heart. Now just count. A queen is this. And then a heart. You count how many we selected. That's 13, 14, 15, 16. So that's 16 total. 52. Yeah. So if one card is selected at random, and that's 52. So we have 16 out of 32 or 52. Right, it's straightforward. More exercise. Now, Stacy has the option to select 3 books to read for a humanity course. The suggested list consists of 10 biographies and 5 current events. She decides to pick the 3 books at random. Find the probability that all 3 books will be biographies. So this is like the case where we draw the tree diagram. However, if we draw the tree and that actually that's not that much. There's only 2 types of books, biographies and current event. And then for each case we have biography and second biography and current event on the second stage, and then the third stage. So more likely we have end up being the tree of like this. But once again, the probability will be different every time. Right, actually, just do that. So first book to choose from, biography or current event. And then the probability for that, there are 10 biography. Out originally, there's 15 books. There are 5 current event. 15 books. Next, we're on the second stage. Biography and current event. Now, if the first one is a biography, there's only 9 left, and there's 14 books left to choose from. Current event, there's still 5, but still over 14. Right. If the first one is current event, there's still 10 biography left, but there's only 14 books. And then if the first one is current event, there's only 4 left to choose on the second time, and that over 14. Then we have biography, current event, we don't have to draw a tree diagram like this, just focus on the case that we want to. Right, I just want to do this so we get a picture. Get a picture of what the problem is. So if the first one is biography, the second one is biography, then there are only 8 left out of 13. And then the current event, we haven't selected any current event yet in this path, so still 5 over 13, and the rest. The problem asks us to find the book that all 3 books will be biography. So this path, all we do is just trace along this path, biography on the first one, on the second one, and on the third. Or we write in slot. The first biography book is 10 over 15, and then 9 over 14, and then 8 over 13. Again, I multiply straight across on the top, divide by straight across from bottom. Like that. Right. Of course, we can convert to fraction. 24 over 91. Right, just like that. Of course, we don't have to complete the whole tree diagram like this, but we can. I just want to write like that. Right. There are 12 women and 5 men in the seminar course. Professor chooses 4-person group at random. What is the probability that the first group chosen will consist of all women? Now, interesting. How do we do something like this? Right. So the most fundamental things of probability is that we find how many we have in the sample space. and then we have how many we have in that certain event, and then we divide them. That's the principle of counting. The most fundamental form of probability is just that. Right. Now, there are 12 women and 5 men. So how many possible ways to choose from? Of course, we choose 4-person group. So we're going to have 12 plus 5, that's 17 people. And we're going to choose 4 of those 17. So this is the total possible group of 4 out of 17. So that everything in the sample space will be a combination of 4 out of 17. So 17 math, that to 4, so 2380. So that is the total possibility. So that's the number of in sample space. What is the probability that the first group chosen will be all women? Alright, there are 12 women. And if all 4 of them chosen to be women, so we have 12, choose from 12. And we have that 495. And this is the number in that particular event of all women are chosen. So probability of getting that event is EB all women group. Right. And right, that's 99 over 476, or we can write a decimal 0.208, or like 20.8%. Right, next, a combination log has 40 numbers on it, 0 to 39. Find the probability that the combination to unlock it consists of 3 numbers. It will contain 1, 2, 3 in some order. Assume the number cannot be repeated in the combination clock. Of course, that's not really true. We might have the first and the last number the same, for instance. Right, now there are 40 numbers, and to open it, to unlock it, consists of 3 numbers. So consists of 3 numbers out of 40 numbers. So the possible outcomes, we write the number of sample space here. We can choose any 3 of them. How would right? Consists of 3 numbers. It will contain the number. Okay, so it had to be a permutation. Now because order does matter here, right? Select 3 of it. 59,280. And then to get to a particular event, 1, 2, 3 in some order. Well, we can choose 3 of those. So 1, 2, 3, 3, 2, 1, 2, 3, 1, something like that. So that choose 3 from 3. And that gives us what? That's 3 factorial will be 6. 6. And then we just divide them. Probability of getting that event. Right. Right. A very small number. Almost 1 out of 10,000. Right. Next, find the probability that the combination log has the 3 numbers. It will contain the number 1, 2 in some order. Right, so I have to have 1 and 2 in it. Right. So what do we have? So it could be 1, 2, and then an x. An x could be anywhere from 3 to 39. Or 2, 1, x. 1, x2, 2, x1, x1, 2, and x2, 1. So those 6 scenarios. And each time there's 38 choice for that. Right? So to choose 1, to choose 2, there's only one option. X could be anyway, so that'd be 38 for the 1, 2, x combination. The 2, 1, x combination, there's only 38 ways. Yeah, so the number in this case (38) each. So that's 38 times 6. So that's 228. And then you have 228 divided by 59280. Right. 1 over 260, which is about 0.00385. Right. Next, a 4-person crew for the International Space Station is to be chosen from a candidate pool of 10 Americans and 8 Russians. Find the probability that all American crew. Right. So there are 10 and then 8. Now this is unlike the clock or the does matter. This one, the crew put on a spaceship and then go. So the order doesn't really matter. So that case, we want a 4-person crews out of 18 people in total. So the number of sample space is going to be, we choose 18 and we're just going to choose 4 out of those 18. Doesn't matter Americans or Russians. So that's 3060. And then all American crew. All American crew is where we select from 10 Americans, 4 Americans out of 10. So that's 210. So with that probability to get the event is n of E over n of S 216 over 3060. I don't know how to write 216 where's clearly 210. Sorry. Right, so if that divide by 3060. So that's 0.0683. Right. So again, this is the crew, so the order doesn't matter. And there's 18 of them. We select 4 out of 18. That's what we have. And then if we want all American crew, we choose 4 out of 10. So that's 210 and divide them. So that's what we have. And with that, we finish section 11.5. Thank you for watching and see you in another video in Math 1332.